Hello, this video is going to be on laws of exponents and simplifying radicals. So we are going to briefly review some of those. When you have anything to the 0 power, that will give you a 1. Anything to the 0 power. So what is here to the 0 power? The 4, the x cubed, or both of them? Well, the exponent is just above the parentheses, which means that exponent applies to everything that's inside the parentheses, and so that whole thing here just goes to a 1, because what we have is 4x cubed to the 0 power. It will be different, so this is not the same as if this would be 4x cubed to the 0 power, right? Because here only the x cubed is to the 0 power, and so that will go 4 times 1, which will be 4. So those are not the same thing, right? Not to be confused. All right. When we have a fraction, positive or negative, it doesn't matter. We have a fraction to a power. This exponent is going to be applied to both the numerator and the denominator, and same here. So for this fraction, we're going to have a negative 2 cubed divided by 3 cubed multiplied by, right, that's a multiplication. Again, this exponent is outside the parentheses, so it's going to be applied to both numerator and denominator of this fraction. So it's 3 squared divided by 2 squared. All right, so let's keep doing. We have the negative in the front here, so it stays 2 cubed and 2 squared. Those are the same bases with a multiplication between them. So because we have the same bases, we're going to subtract the exponent. So 3. Why do we subtract? Because 1 is in the numerator, 1 in the denominator, so we subtract. So 3 minus 2 is 1, so that's going to be a 2 to the first power. I'm going to write it down so we see. And here I have a 3 squared and a 3 cubed, so again the same bases of 3. It's a multiplication between them, so we can actually subtract those exponents. So 2 minus 3, so that will be a 3 to the negative 1, which tells me that 3 is going to go to the denominator as a 3 to the first power. So it will be negative 1 if it will be in the denominator, in the numerator, right? But then we write it at the bottom. So what does that become? It's a negative 2/3. Okay? We have a multiplication of two terms here, or two expression. So this 4 does not have an exponent applied to it, right? That negative 2 only applies to the y because it is not outside the parentheses. And this 6 only applies to the y as well because it is not on the outside of the parentheses. So the 4 doesn't have an exponent, the 8 doesn't. So 4 times 8 is going to be 32. And then we have a y to the negative second and a y to the 6. So I'm going to write them like that. We multiply the same bases, right? That's a multiplication between them. So we're going to add the exponent. So 32 times y to the negative 2 plus 6, that's a positive 4. And that will be the answer. Here we have a 6x to the 4. So this 4 only applies to x, right? Not to the 6 because there is no parentheses. And then this x has a 0 power, and we talked earlier how anything to the 0 power goes to 1. So this x here goes to a 1. Attention, not the 2. The 2 is not to the 0 power, only the x, right? So that says 2 times 1. So we have 6x to the 4th times 2 times 1, which is 2, and that's to the negative 2 power. A negative power means we need the multiplicative inverse. So because that's a 2, we're going to write it as an over 1, and then we're going to flip that fraction, right, the multiplicative inverse. So that will be 6x to the 4th, and that becomes times 1 over 2 to the second. So it becomes a positive exponent now because we moved the base down in the denominator, right? And 2 to the second is going to be 4. So we're going to have 6x to the 4th over 4. And then I can simplify that will be 3x to the 4th over 2. There we go. Alright, we have a negative exponent, and we know that when we have a negative exponent, we need a multiplicative inverse. So we would flip this fraction around. We could do it this way, or we could distribute this exponent first and then see what happens. But I like to get rid of that negative, so I'm going to do multiplicative inverse. So I want 5 over x to the negative 3, y to the 4th, and all of that is now to the positive 3. Positive now because I did the multiplicative inverse, right? So I flipped it. And now this exponent of 3 is going to be applied to everything that's inside the parentheses. So we have a 5 cubed over a power to a power. We're going to multiply them. So 3 times 3 is 9. So that's x to the negative 9. We still have that negative to take care of in a minute here. And then y, a power to a power, we multiply them, so it will be 4 times 3 is 12. Okay. 5 cubed is 125, so that becomes 125. X to the negative 9, so that means this is a negative exponent, so this has to be moved back up in the numerator, so x to the 9, it's now positive because we moved it up. We did the multiplicative inverse, right? And then y to the positive 12, so that stays in the denominator. And that's as far as we can simplify. Alright, number 6, we have an x squared times x to the n divided by x to the n times x cubed. Well, when you're multiplying the same bases, you add the exponent. But here you need to notice that because that's a multiplication and that's a multiplication, we have a factor of x to the n and a factor of x to the n, so we can cancel them because x to the n over x to the n becomes 1. So we're going to end up with an x squared over x cubed, right? Because that becomes a 1. And now we still have the same basis, so we subtract the exponent. So x to the 2 minus 3 is an x to the negative 1. And because that's a negative exponent, we need the multiplicative inverse, so make that over 1 and flip it. So it will be 1 over x to the first power, so just 1 over x. I'm going pretty fast, but this should be a review, so if you don't understand or if I'm going too fast, just stop the video and rewind and listen to it again, okay? I have a 16 over 27 to the 1/3. So first we have to remember what is an exponent that's a fraction. Well, it's a root. And because the denominator is a 3 here, that's really going to be a cube root, right? So a fractional exponent is a root, and the index of the root is the denominator of that fraction. So we have a cube root of 16 over 27. And then we have to ask ourselves, 16 is the same thing as 2 to the 4th, that's still in a cube root, and then this here is the same thing as 3 cubed. 27 is 3 cubed, okay? So when I have a cube root of something cubed, those are inverse operations, so they cancel each other out, so I'm left with just an over 3. The cube root of x cubed is just going to be 3. 3 cubed, not x. And then here I have a 2 to the 4th. So that means that this will be the same thing as the cube root of 2 cubed times 2, just so that you can see what's happening, right? 2 cubed times 2 will be, add the power, will be 2 to the 4th again. And then a 2 cubed in a cube root, those are inverse operations, so we would have a 2 coming out, and this to the first power has to stay, so I have a 2 times a cube root of 2 all over 3. There we go. Here this is a square root, and I have a 54, so I have to ask myself, 54 would be what? It would be 6 times 9, right? And so if I take a square root of that, I can take the square root of 9, it comes out as a 3, but I cannot take a square root of 6. So the 54 becomes 3, and then a square root of 6. So that's for 54. Now we need to look at x to the 8. This here is a little index of 2. We don't usually write it for a square root because it's the most common one, so we don't write that 2, but it's an index of 2. So we want to ask ourselves, 8 over 2 simplifies to a 4, so that's going to become an x to the 4th power on the outside. And then 6 over 2 would simplify to a 3, and so that would be a y cubed. Oh, I need more room on that one, so let me make a little bit more room here. So 6 over 2 is 3, so that's a y cubed, and we still had that 6 here in our cube root that was left over. So we don't have a variable left in the cube root, but because we started with an even root, we cannot have anything inside an even root that's a negative number. Well, we know 54 is not negative because we see that, right? We don't know what x is, but we don't have to worry about it because even though it's inside the square root, when it comes out, it's still going to be to the 4th power. So if x is a negative number to an even power, that's still going to become a positive value. However, the y was inside the square root. We don't know what y is, and when it comes out, it becomes y cubed. If by chance y is a negative number, that would be bad because we cannot have a negative number coming out of an even root. So we're going to have to put absolute value around the y to guarantee that this is positive. So why do we have to do it here and not here? Again, because this x is still to the 4th power. So if x by chance would be negative, the 4th power will take care of that negative and make it change to a positive. Y, however, is cubed once we simplify it out of the square root. And because a cubed does not guarantee a positive value, we have to make sure we guarantee that by putting absolute values. All right. Now we want to add 2 roots, and those have to be simplified first. So let me switch colors here. 20 is the same thing as 4 times 5, so that's going to be a square root of 4 becomes 2, so that comes out as a 2. But there was already a 2 in the front, so those two 2's will be multiplied. So 2 times 2 is 4. A square root of x is squared is going to be just an x, but again I need that absolute value because I need to make sure this is going to be a positive value. It was in a square root after all, right? And then the 5 here stays, so I'm going to have a square root of 5 plus 125 is going to be the same thing as 25 times 5, and then that here, square root of 25 becomes a 5, and I already had a 5 here, so those two 5's are also going to be multiplied, so that comes 25. The x squared in the square root comes out as an absolute value of x, and then this 5 has to stay in the root. And because we have a square root of 5 and a square root of 5 and an absolute value of x and an absolute value of x, those are like terms, so we can just go ahead and add the coefficients. So this is going to be ending up being 4 plus 25, which is 29, absolute value of x, square root of 5. That was a little tricky right there. A lot of things going on in that problem. All right, number 10. Notice how we have a negative exponent. We already talked about those, so that means we need the multiplicative inverse of that fraction. So we're going to flip it around to change this exponent to a positive. So that becomes 81 over 16. See how I did the multiplicative inverse? And now that here is going to be a positive exponent because we took care of that negative. And now I have two choices. I can either cube those numbers first, then take a 4th root, or I can take a 4th root first and then cube. I want to take the 4th root first, make those numbers smaller, then I'll cube them. So I want to take the 4th root of 81 over 16, and then once I have that 4th root, I'm going to cube this. The 4th root of 81, well, that's just going to be a 3, and the 4th root of 16, that's going to be a 2. And now I want to cube that. So 3 cubed is 27, and 2 cubed is 8. So that will be my final answer right there. Here I have a negative exponent, but I do not have a fraction, so I'm going to write it over 1. So now I can do the multiplicative inverse. So that will be 1 over 32. And now I don't need that negative anymore, so it will be 3 to the 5th. And just like above, I can cube first and then take a fifth root, and take a fifth root first, which is what I want to do. Make the number smaller first. So I have a fifth root of 1 over 32, and then all of that will be taken to the third power. The fifth root of 1, well, that's just going to be a 1. And the fifth root of 32, well, that's just a 2. And then all of that cubed, well, 1 cubed is just 1, and 2 cubed is 8. So that's 1 over 8. All right, so here we have cube root. 54 is the same thing as 27 times 2. And why do I want that? Because the cube root of 27 is actually 3, so that comes out as a 3. I already had a 3 outside, so I need to multiply those two. So 3 times 3 is 9. And a cube root of x cubed, that just becomes an x. And then I still have that 2 inside my cube root, so cube root of 2. And you're going to say, well, why aren't you worried about an absolute value here? Well, I'm not, because that's a cube root, and you could have a negative value coming out of a cube root, of an odd root, so there is no problem here. We don't need absolute values. All right, so 16 here. 16 is the same thing as 8 times 2, and why do I want to work with 8 and 2? Because the cube root of 8 is just going to be a 2, so that comes out as a 2. There is no number in the front, so that's just going to be 2. And then this stays inside. Cube root of x cubed is just x. And so then I have a cube root of 2. And now those are like terms, because I have an x times cube root of 2, x times cube root of 2, they're like terms. So I have 9 of those, and 2 of those. 9 plus 2 is 11 x cube root of 2. All right. Then here we have a negative exponent, means that has going to be moved in the denominator. So notice how it is the same bases. So in this guys, that's going to be a 2x plus 1 and a 2x plus 1. They're the same bases. So when we have the same bases, we actually add the exponent when it's a multiplication between them. So that becomes 2x plus 1. Oops, sorry. I'll put my plus between them. 2x plus 1. And I'm going to add those powers. So I want 5 half plus a negative 5 third, right? So what is 5 half plus a negative becomes minus, right? So minus 5 over 3. Well, we need a common denominator here, so I'm going to multiply this fraction by 3 and this one by 2. So that becomes 15 minus 10 over my common denominator now of 6, right? So 15 minus 10 is going to be 5 over 6. So this is going to become 2x plus 1, keep the base, to this power, to the 5 over 6. And I'm going to keep this like that. I'm not going to change anything more. Because that's a binomial, I cannot distribute an exponent over a plus or a minus, right? We cannot do that. We need to see if we can simplify that. So square root of 32. Well, 32 is the same thing, so I'm in a square root, so I'm looking for a perfect square in 32. Well, 32 is the same thing as 16 times 2. And 16 is a perfect square, so it will come out of this root as a 4. And then 200 is the same thing as I'm looking for a perfect square. So perfect square of in 200 will be 100. So 100 times 2. And when I take a square root of 100, that becomes a 10 on the outside. So I'm going to end up with a 4 square root of 2 plus a 10 square root of 2. And those are now like terms, right? I have 4 square root of 2s and I have 10 square root of 2s. When I add them all together, I would end up with 14 of them. So 14 square root of 2. There we go. That's your review on laws of exponents and radicals.